Hello everyone! In this video I will present the PCG RandomAssembly tool, finally available on FAB, what it does and how to create one from scratch. There is an example level here, with an assembly already set up. Few 3D assets are available as well for you to test. Here is the assembly already set up in the example level. You can see if I click the generate buttons, it randomizes props positions, scale, and on the benches as well the materials. So to create one from scratch, let's go first in the 3D assets folder, and we will place few static mesh actors to build a small level instance. So let's start by a table, and we will place few drinks meshes on it. So let's just add a few more like this. Okay. So actors in the level instance will need also actor tags to be set on them, just to be able to link a randomization variant to them. So let's select all the drinks here, and we will add as actor tags drink. And for the table, we will add one called table. Once it's done, you can select all the meshes and create a level instance. So to do that, you right click on them, level, create level instance. We don't need external actors on such a small scale. We click OK, and I will put it in my developer folder in a new folder. Let's call it level instance table example. So now you have your level instance in the level. To create a random assembly, you go to the level instance freshly created, and all you need to do is to right click on the level instance, asset, scripted asset action, PCG RandomAssembly, create random assembly. You can leave the two options checked on. It will ask you if you want to create a random assembly definition and spawn an actor in the current level, a random assembly actor. So that's what we want to do. You click OK. I will put the data needed in the same folder as the level instance. So the first one is the PCG Data Asset. So you can see it has a PCG prefix. You click Save. And now it will ask you where to save the random definition data asset. The default name is OK for me, and I will put it in the same folder as well. When you click Save, you can see now it has created a new data asset with a random definition, and it spawned a random assembly with the right definition set to it already. So if you open the editor here in the freshly created random assembly, you can see here that we don't have any randomization parameter set for now. No variant. So you can click this button here, and it will spawn the list of tags available for you to add a variant to. So let's start with the table. We click on the create button. Same thing, I will put it on the same folder. So it's called by default table var, which is fine for me. I save it, and it opens the variant data asset for you. You can set a debug color. So the first thing you want to do for this variant is to click on direct spawn. In this case, we're sure that the table will be available as collision data for the next variant, for instance, the drinks. And then we can add a bit of offset as well. And Z rotation, let's say -15 to 15. For the projection to work correctly, we also need to add a bit of Z offset as well. More on that later. We click on the project landscape and project on wall static as well, because we want the table to be always projected on the ground, let's say. I save it and I close it. And now if you click the generate with new seed button, you can see that the table is updated according to your variant settings. Now let's continue with drinks. So again, you can create a new variant. There is only drinks available for now. You click create. Drinks var is fine for me. I save it. And now we can add more variation in rotation, but also maybe a bit of scale variation. We also click project on wall static and landscape. Let's change the debug color as well to not make it the same as the table. And what we're going to add for this variant as well is mesh variant. So mesh variant is a list of static mesh to swap the current model with. It's a weighted list. So you have this weight parameter. So let's, for instance, add this clay pot, the regular drink we had as well, and maybe, I know it's not a drink, but let's add a bit of bread. You click save, and now if you click generate, you can see it updates the props accordingly. We can also have some, let's add also a Z offset to be able to fix this bread projected on the ground. And we can also add a removal probability. So let's add that to 0.5. So that means like you have 25% of chance to remove the actor, the current actor. So you can see now we don't have all the props all the time. Okay. If you update the level instance, so if you want to add props, for instance, or remove props or change tag or something like that, you can do it using the edit button here on the level instance directly. So let's say, for instance, we want to add a bench, two benches. So let's add those here like this. And we can leave it without a tag if you want. Let's, for instance, also add another drink here. Once you're done editing your level instance, so you click the save button here. But what you have to do as well is to update the PCG data with a new level instance object. So you can see here, for instance, you don't see the bench on the new added drinks. But if you go in your random assembly widget, you have this button here, update the PCG data asset from level instance data. You click. In the example level, you also have an example of this random assembly here being applied on a larger scale using a PCG graph itself. So you can see here you have all this table applied on a grid pattern, and if you move them, they are randomly updated and projected according to variant settings. So you can see it's a regular PCG component with a dedicated template graph in it. So that means you can see the name of the graph is start with TPL. If you create a new PCG graph, it will be available in this template list, process random assemblies. If you open the graph, you can see that we start by creating a grid with a few points. And PCG graph as a parameter a random assembly definition array. By default it has 0, but on the level we added 1. So after the point generation, so in this example it's a grid, but it can be like points sample out of a landscape or any of the system you might have. Using the match and set attributes, we add the random asset definitions to the points as attribute. It's very important that the attribute name is random assembly definition. Then we partition the points out of the random definition attribute. Because the process random assemblies is a loop, we loop through each random assembly definitions. So that means we can have multiple random assembly definitions on the same graph. And it's only this graph which will evaluate all the random assembly definitions and output the instances out of it. So if I go back to the PCG component, you can see in the parameter override, we have one table random assembly, which is this one here. For the demonstration, let's say I want to add the assembly we created from scratch. So if I add a new entry here, you can see like almost half of the points are now outputting nothing because there is no random definition applied to it. And if I drop this here, you can see you have this new random assembly definitions assigned to the PCG graph. You can see that the benches are floating because they don't have any tags and they're not then projected on the ground. But we can fix that quite easily. First, let's go to the level instance, edit, select the two benches, tag, let's use bench, we save, and now we go to the assembly definitions, to the assembly actor, sorry, update the data asset, and add a bench variant. Let's add it to the same folder as well. And let's add a bit of randomization in, let's change the table color as well. And maybe a bit of offset. And projects and landscape and world static. We save. So now if I click generate, you can see the benches are also a bit randomized. And if I go here and force the generate again the PCG, you can see now the benches are projected as intended. And that's it for this part. Thanks for watching.